Module 7, Chapter 4.3, Rational Equations and Inequalities. A rational equation is an equation with at least one term having a variable expression in a denominator, or at least one term having a variable expression raised to a negative integer power. For example, x plus 2 over 2x plus 1 equals 1 is a rational equation. 3x to the negative 2 plus 4x to the negative 1 plus 1 equals 0 is a rational equation. X plus 2 over x plus 1 plus 1 over x plus 2 equals 8 over x squared plus 3x plus 2. Notice you either have an x in the denominator or you've got x to a negative exponent. To solve a rational equation, multiply both sides of the equation by the least common denominator. Remember that an expression with a variable denominator or a negative exponent may be undefined for certain values of the variable. We must identify these values. Solve x plus 2 over 2x plus 1 equals 1. Remember way back in beginning algebra we learned if you have an equation with a fraction in it, multiply both sides by the LCD. So in this case, the LCD is 2x plus 1. So we're going to do both sides by 2x plus 1. So on this side, we've got 2x plus 1 times x plus 2 over 2x plus 1 equals 1 times 2x plus 1. Left side, 2x plus 1 in the numerator and the denominator cancel, so we get x plus 2. On the other side, we get 1 times 2x plus 1, which is 2x plus 1. Notice this is first degree, this is linear. So to solve a linear equation, we get x to one side and numbers to the other, and we get x is equal to 1. Now, what you have to watch out for, though, is you cannot have x being a number that makes your denominator 0. So we always need to go in here and say, okay, let's see what would make this fraction undefined. So it's undefined if 2x plus 1 is 0, or it's undefined if 2x is negative 1, or it's undefined if x is negative 1/2. So as long as our solution is not negative 1/2, then that satisfies the solution. Okay, let's do another one. Now on this one, we've got an equation with fractions, so let's multiply both sides by the LCD. Well, to find the LCD, you factor, and then you put all the common terms in the LCD. So in this case, LCD would be x plus 2, x minus 2. So if we do both sides by x plus 2, x minus 2, and then when we distribute it, what happens is all the terms get that LCD. So we get x plus 2, x minus 2 times the first term, plus x plus 2, x minus 2 times the second term equals x plus 2 times x minus 2 times the third term. Now I'm just going to go ahead and bring down the factored form so that we can cancel a little bit easier. First term, x minus 2's cancel, so we get x times x plus 2. Second term, x plus 2's cancel, so we get 1 times x minus 2. Third side, x plus 2, x minus 2 cancel, and we just get 8. So multiplying this out would give us x squared plus 2x plus 1x minus 2 equals 8. Now notice this is quadratic. To solve a quadratic, we want to set it equal to 0, so we get x squared plus 3x. If we subtract 8 from both sides, we get minus 10 equals 0. Now we have to decide how we want to solve that. That one's going to factor, so we'd get x plus 5 times x minus 2 equals 0. setting each factor equal to 0, we get x equals -5. Or setting x minus 2 equals 0, we get x equals 2. Now, but remember, we always need to go back and find what makes this problem undefined. So we say, well, this problem will be undefined if the LCD is equal to 0, which means x minus 2 times x plus 2 equals 0. So it's undefined if x minus 2 is 0 or if x plus 2 is 0, which means it's undefined if x is 2 or if x is -2. Now, because our solution had a 2, we throw it out, not a solution, because it makes the denominator 0. So our solution for this one would just be x equals -5. Okay, let's do another one. Solve the equation 1 minus 13 over x plus 36 over x squared. Same thing, multiply both sides by LCD, which in this case, LCD would be x squared. So we're going to do the left side by x squared. We're going to do the right side by x squared. So we get x squared times 1 minus x squared times 13 over x plus x squared times 36 over x squared equals the other side, x squared times 0. So we get x squared minus, second term, this x will cancel with the square, so we get 13x. Other side, x squareds cancel, and we get 36. Right side, we just get 0. This will factor x minus 4 times x minus 9. So we get x equals 4 and x equals 9. But because we had a variable in the denominator, we need to go back and say, okay, it's undefined when any of the denominators are equal to 0, which it's undefined if x squared is 0, which means x is 0. We did not get a solution of x equals 0, so there's our two solutions. Now, what about inequalities? To solve a rational inequality, if necessary, rewrite the inequality so that 0 is on one side and there is a single fraction on the other. Find the values that will make either the numerator or the denominator equal to 0. These will be the locations of the intervals on the number line. And then test a value in each interval to determine which intervals form the solution set. Okay, it said, if necessary, rewrite so that we get 0 on one side. So we are going to do minus 1 on both sides. So what we have is x plus 2 over 2x plus 1 minus 1 is less than or equal to 0. Well, now we need a single fraction on this side. So what we're going to do is say, well, LCD is 2x plus 1. So this becomes x plus 2 over 2x plus 1 minus 2x plus 1 over 2x plus 1. And that's less than or equal to 0. Well, once we've got the same denominator, we can combine those, which will be x plus 2. Now remember, this minus affects everything behind it. Minus 2x minus 1 over 2x plus 1. And that's less than or equal to 0. Which says 1x minus 2x would be negative x. Plus 2 minus 1 would be plus 1 over 2x plus 1 is less than or equal to 0. Now remember what the second step said. Let's back it up. It says find the values that will make either the numerator or the denominator equal to 0. Well, the numerator, negative x plus 1 equals 0. If you do minus 1, you get negative x is negative 1, or x equals 1. Okay, so the numerator will be 0 if x is 1. The denominator will be 0 if 2x plus 1 is equal to 0, 2x is equal to negative 1, or x is equal to negative 1/2. So what we do is we come over here on our number line, and we put 1 and negative 1/2 on our number line in order from left to right. So there's negative 1/2 and there's 1. And then we pick intervals to see which ones work. So if we pick 0, because that's in the middle, we get 0 plus 2 is 2. 2 times 0 is 0. 0 plus 1 is 1. 2 over 1, is that less than or equal to 1? No, which means nothing in that middle interval will work. Pick a test point to the right of 1. Let's try 2. 2 plus 2 would give us 4. 2 times 2 is 4. 4 plus 1 is 5. 4/5 is less than or equal to 1. Is that true? Sure, 4/5 is less than 1, which means this entire interval would work. Same thing back here. Pick a number less than negative 1/2. Well, let's pick negative 1. Plug it in. Negative 1 plus 2 would be 1. 2 times negative 1 would be negative 2, plus 1 would be negative 1, which would give us a value of negative 1. Is negative 1 less than or equal to 1? Yes, so that interval is in there. Now what you have to consider is because this is less than or equal to 0, normally we say that includes these endpoints. Okay? But remember, the denominator cannot be 0. So the solution that made the denominator 0, which was negative 1/2, is not included in the solution, whereas the one that made the numerator 0, that would just make the whole fraction equal to 0, and that one's okay. So our interval notation would be from negative infinity to 1/2, not including also 1 up to infinity, but it includes the 1. Okay? Now let's do another one. This one's sort of a 3-part one. The first thing we're going to do is find where it is equal to 2. We're going to multiply both sides by the LCD, which is 5 minus 3x. So x's cancel, so we get 6 equals 2 times 5 minus 3x. 6 is equal to 10 minus 6x. Minus 10 minus 10, so we get negative 4 equals negative 6x. Divide both sides by negative 6, so we get x equals 2/3. So that would be our solution. So remember, we've got to make sure, does it make the denominator 0? Well, the denominator would be 0 if 5 minus 3x is 0, or negative 3x is negative 5, or x equals 5/3. So we're okay for our solution. Now, for the inequalities, we would like to set it equal to 0. So we're going to do minus 2 on both sides. So we get 6 over 5 minus 3x minus 2 is less than or equal to 0, which would give us 6 over 5 minus 3x minus 2 times 5 minus 3x over 5 minus 3x is less than or equal to 0, which would give us 6 over 5 minus 3x. Now if we distribute this negative 2, that would be minus 10 plus 6x over 5 minus 3x, which would give us negative 4 plus 6x over 5 minus 3x. And these are all less than or equal to 0. So once you get a fraction less than or equal to 0, you find what makes the numerator or the denominator or both 0. So the numerator equal to 0 would be negative 4 plus 6x equals 0. 6x equals 4 or x equals 2/3. The denominator equals 0 would be 5 minus 3x equals 0, or 5 equals 3x. Divide by 3, and x is 5/3. Now, do these numbers look familiar? 2/3, 2/3, 5/3, 5/3, and we came about them two separate ways. Okay, now for the graph, or for the equation, it's just a point. Now for the inequalities, we'll come up here and draw our line up here. You mark both of those. So there's 2/3 and there's 5/3. Let's draw up our little intervals. Pick some points. Well, 0's back here, so if you plug in 0, you get 6 over 5 minus 0, which is 5. 6 over 5 is less than or equal to 2. That's true. 1 1/5 is less than 2, which means we're going to shade this interval. Between 2/3 and 5/3 is 3/3, so if we test 1, we would get 6 over 5 minus 3 times 1 is 3. 5 minus 3 is 2, which is 3. Is 3 less than or equal to 2? No, which means 1 didn't work. Pick a number greater than 5/3. Try 2. We'd get 6 over 5 minus 3 times 2 is 6. So 6 over negative 1 is negative 6. Is negative 6 less than or equal to 2? Yes. So we're going to shade that. Now in this case, it's less than or equal to, which means normally we include the endpoint. The numerator, which was negative 4 plus 6x, which gave us 2/3, we're going to include that numerator. 5/3 is the one that makes the denominator 0. We never include that. So our interval notation would be negative infinity to 2/3 union with 5/3 to infinity. Okay, the only difference would be these are greater than or equal to 2. Well, 6, this is not greater than or equal to 2, which means no, this one would not work. 3 would be greater than or equal to 2, which means yes, this one would work. And negative 6 would not be greater than or equal to, which means this one did not work. So for the greater than or equal to, we have just the opposite. We have the interval from 2/3 up to 5/3. That's the solution, and the other two intervals do not. Okay, and then we've got one we can do on our calculator. That one's about too ugly to do pencil paper method. Okay, so to do this one in our calculator, we get parentheses, the square root of 2. Now notice it's just the square root of 2 under the radical. X plus 5, that's in the numerator, divided by, down in the denominator, we've got x to the 3rd power minus the square root of 3, close the parenthesis for the square root and close the denominator. And then y2 is going to be 0. We're going to graph that on our Zoom 6 screen, and we get this little weird thing right here. Does this graph ever cross the x-axis? Well, remember, this is a vertical asymptote through whatever x cubed minus the square root of 3 is. Well, let's just check. Second trace, number 5, enter, enter, enter. Now notice there's two pieces of the graph. So we've got one down here and we've got one up here. Well, the one down here says yes, it does cross, and it crosses at x equals negative 3.5355. Then we probably need to come over here on this side and go second, calculate number 5. Now when it asks us for the first curve, we might want to bring our cursor over and make sure that we're on that second half of the graph. Enter, y2 is 0. Do we have to guess? And it's thinking, which means it's probably never going to cross the x-axis. And that's what that little error message means. Okay, so we have one solution. Now on this one, we're trying to find where this function is greater than 0. Now think about it. This one crossed at negative 3.55, and then it probably went on back this way. So it's going to be above the x-axis, or it's going to be positive from negative 3.5355 backwards. So that's from negative infinity to negative 3.5, we'll just call that negative 3.54, and it does not include it. Now over here on the other side, it's always above the x-axis. So in that case, we're going to say, well, you know what, it's union with, well, where does this start? What is this vertical asymptote? Well, what we've got is x to the third minus the square root of 3 equals 0, or x to the third equals square root of 3. We're trying to solve that. What we would do is, let's clear this out for a minute. X to the third power, and then the second part would be the square root of 3. And let's find where those intersect. Second, calculate number 5. Enter. It probably wouldn't be a bad idea to do this first, so we didn't have to stop our graph, which says that x is equal to 1.2. Which means if we go back to our original problem, we would have a vertical asymptote right here at 1.2. We would have where it crosses the x-axis at negative 3.5 right here. So what we would have is a graph that went through here. This graph went this way. So we said, well, it is above the x-axis from negative 3.5 backwards, and it's also above it this whole way over here, which would be from 1.2 to infinity. Now, where on this graph, for C part, where on this graph is this function below the x-axis? Well, it's below the x-axis right in here, which means from negative 3.54 all the way up to that vertical asymptote of 1.2. Now remember, less than and greater than, we always put parentheses on our interval notations. Okay, I hope that helps. Now you're ready to do this section of homework on my math lab.